In question 4 asks you to use the given zero to find all complex zeros of the function, and then write the linear factorization of the function. So I gave you that 3 plus I is a 0, and because it's a 0, we can use synthetic division to run through and find a remainder of 0 and decrease it from a 4th degree to a 3rd degree. So I'm going to bring down the 2, and then we take 2 times 3 plus I, and that's going to be a 6 plus 2I. We're going to add our like terms, and that's going to be a negative 11 plus 2I. Now I got to take that negative 11 plus 2I and take it times 3 plus I. So 3 plus I, I got to take it times negative 11 plus 2I. So we got a negative 33, we got plus 6I, then we got minus 11I, then we got plus 2I squared. Well, these are like terms. We got negative 33, then we've got a negative 5I, and then this I squared is a negative 1 times a positive 2 or minus 2. So what we're going to put in there is a negative 35 minus 5I. So this is going to go up on our next line, so it's a negative 35 minus 5I. Should give me a little more room in there. Like to select that one over, and this one over, and this over a little bit. And then we're going to collect our like terms. And 52 minus 35 is 17 minus 5I. So now I got to take that 17 minus 5I, and we have to multiply it times our 3 plus I. So I'm going to do that scratch work over here. So now it's 3 plus I times our 17 minus 5I. So 3 times 17. 3 times 17 is 51, and 3 times a negative 5 is negative 15I, and I times 17 is a positive 17I, and then that's going to be a negative times positive, so that's a negative 5I squared. So it's 51, then we got to collect our like terms, so plus 2I, and this is a negative 1 times a negative 5, or plus 5. So that should give us a 56 plus 2I. So that's going to go underneath our 62, so it's 56 plus 2I. We're going to collect our like terms, and 62 minus 56 equals a negative 6 plus 2I. And now I got to take that number times 3 plus I. So now I got 3 plus I times negative 6 plus 2I. So that's a negative 18. Then we have minus 6I. On the inside we have, that's an error, that's a plus 6I on the outside, so plus 6I. On the inside is a minus 6I. And on the last term you got a positive 2I squared. So that's a negative 18. These will reduce. Your negative 1, your I squared is a negative 1, so it's going to be minus 2. And that's a negative 20 total. So put your negative 20 into the 20, and there is your remainder of 0, verifying that 3 plus I is indeed a factor. So now, because 3 plus I is a 0, or I said that wrong before, this is 3 plus I is a 0, then 3 minus I is a 0. They always come in pairs. So we're going to wipe our slate here and start our next row. Remember, that first row is always the toughest, and then after that it gets a lot easier. So it started as a 4th degree, we have it depressed down to a 3rd degree. After I get done with this 3 minus I, I'll be at a 2nd degree, and then I can factor it. So bring down the 2, again you multiply 3 minus I times 2, that's going to be 6 minus 2I. 2i's will cancel, and we're left with a negative 5. Negative 5 times 3 minus I is a negative 15, and that's going to be plus 5I. Reduce, that would give us a 2. And that's going to be a 6. And 2 times a negative I is a negative 2I, and there's our remainder of 0. So now we have it depressed to a 2nd degree polynomial. So now I've got 2x squared minus 5x plus 2. And at this point, I'm going to see if I can get this to factor, or else I can use quadratic formula. So the only factors of 2 are 2 and 1, so it's got to be 2x and x. Again, the only factors of 2 are 2 and 1, and I want to end up getting a negative 5, so I'm going to go minus, minus, the signs have to be the same. I'm going to put the 2 on the outside and the 1 on the inside there, so I'll end up with a negative 4x, negative 5x. So I know I have it factored on that part. On the other side, what I knew is that this was a 0. If this is a 0, then x minus 3 plus I is a factor, and that this 0 becomes, as a factor, x minus 3 minus I. And that's just like I did in the previous example, is to break that down just a little bit further. If I know that these are zeros, then I always take x minus that 0, and that's going to give me my factors, x minus 3 plus I. So that's why this one becomes the x minus 3 plus I, and then you could do the same idea on the other. So what I've done now is I've factored it as a set of linear factors. There should be 4 of them under the fundamental theorem of algebra for our complex solutions. So I want you to find all the complex zeros of the function and then write the linear factorization. So let's take a look at all the zeros of the factor then. So all I gotta do is finish this up. This 0 is a positive half. This 0 is a positive 2. These two zeros we had, they were 3 plus and minus and I. So there's all 4 of our zeros or solutions. So that's what I expected to see on that problem with your synthetic division, your linear factorization, and also your zeros.